hands haven't been.
Welcome to Lab 1 Experiment 2. During this experiment, ask yourself: 1. What did you see? 2. Do you think a chemical reaction occurred? 3. What clues were there? And 4. Where did the bubbles come from?
Every inch of your skin, there's no your hands haven't been. Ain't it funny? 'Cause now there's nothing left but small talk.
Small talk.
Vinegar is an aqueous solution of an acetic acid and trace chemicals that may include flavoring. Vinegar typically contains 5 to 8% acetic acids by volume. Eggs, an oval or round object laid by a female bird, reptile, fish, or invertebrate, usually containing and developing embryo. The eggs of birds are enclosed in a chalky shell, while those of reptiles are in a leathery membrane. This is what our naked egg is starting to look like. You'll start to see bubbles accumulating around the shell of the egg, and also the eggshell creating particles in our vinegar solution. After 24 hours of soaking, remove your old vinegar solution and replace it with new vinegar. Once you've completed that, you will start to see more bubbles, and you'll also start to see your egg kind of clear or translucent through your jar. I'm going to pour out the old vinegar solution and grab our naked egg, kind of rinse out everything and rinse the egg off. I'm cleaning off the excess particles that we saw in the solution in the last slide, just so that we can kind of see the egg really clearly. On one side, you see that it's translucent or clear, and then on the opposite side, there's still some type of hard white shell on the osmosis egg, okay? I squeezed it just to see how it felt. It is a little squishy, kind of like rubber. It does have a little bit of a bounce to it, but I was too nervous to try to bounce it on the counter. Once the egg kind of clears out and becomes more translucent, when you shine a flashlight through it, because the hard surface is gone, the only part that remains is a thin membrane called the semipermeable membrane. You also may have noticed the egg got a little bigger after soaking in the vinegar. Here's what happened. Some of the water in the vinegar solution traveled through the egg's membrane in an effort to equalize the concentration of the water on both sides. I am filling the egg with more vinegar so it can soak for just a couple more days to be ready for our part 2 of our naked egg experiment. Wow, day 4. Look at our naked egg. We can almost see completely through it. Right at the top, I know you can kind of see there is some white right on the top. That's what's remaining. And then as I circle the naked egg around, we've still got a little bit more on that other side that's trying to break down. You can see those bubbles really up close.
Every inch of your skin, there's no your hands haven't been. Ain't it funny? 'Cause now there's nothing left but small talk.
All All right, next is part 2. Let's get started. So I wanted to take our egg experiment to the next level in introducing it to 3 different chemicals. Let's see. I chose carbonated water, salt water, and corn syrup because I wanted to see how the egg would react to these chemicals. Will they get smaller? Will they expand? Will they shrivel? Will they burst? I am curious. All right, it has been a full 7 days, and now our egg is ready. It is completely translucent. There is no more white shell around the egg barrier. It is really squishy and bouncy. I was playing with it when I cleaned it off. If you look closely, you can kind of see the yolk right in the center. This is what a naked egg looks like. And we would consider this the membrane of a cell. In our case, the egg is a semi-permeable, meaning that small particles can go in and out of the cell, while larger particles stay out. Water and other nutrients are small enough to travel in and out of the cell. When the concentration of the water in the cell is different than the concentration of the water outside of the cell, the water will move either in or out of the cell to balance the concentration inside and out. This is called osmosis. Osmosis explains why the egg in the corn syrup shrivels. Corn syrup has a very low concentration of water in it, so some water from the inside of the egg traveled through the membrane into the corn syrup, making the egg shell shrink. It looks like a dried prune, a dried apricot. The outer perimeter is kind of soft, but it's got a little roughness to it. And also our yolk in the center is hard. I tried to squeeze it and nothing happened. It kind of felt like a seed or a rock, kind of.
Every inch of your skin, there's no your hands haven't been. Ain't it funny? 'Cause now there's nothing left but small talk.
Small talk.
Animal talk.
Now we're into our 3rd egg. It's our blue egg, and this one is our carbonated water. In this egg, you can see bubbles in the inside of the egg and the water right through the egg. This shell looks a little thinner than our original clear translucent egg, and definitely it's not shriveled like our red egg. This egg was the one that gave me the hardest of them all because it eventually will pop. So after I realized it was so thin that it had popped, I decided to still show off the yolk and the skin around the yolk. I had to rinse off the blue egg just because I had lots of product on my hands. So there is the outer shell of the egg. It's like a little thin piece of skin almost. And then we have our yolk. I kept the yolk. The yolk was a bit tougher than a normal yolk. And also the yolk was swollen. It kind of was expanded from the carbonation in the water, in the carbonated water. So this is our carbonated water osmosis egg that popped. Last but certainly not least is our saltwater solution egg. This one reminds me the closest of a boiled egg, just by the looks of it. As I was looking at this egg, once I looked closely, I could definitely tell there was some type of solution with our membrane mixed inside the egg. You'll see particles shifting inside of our egg. I thought this was super cool. It's definitely got a bounce to it, just like our original translucent osmosis egg, but it's definitely different. It's got a little bit harder perimeter, still squishy, but a little more tougher on the outside, which was why I was able to squish it so much. It was super fun. But that is all of our eggs. So I hope everyone enjoyed this experiment and stay tuned for more videos. Self-discussion. Does a chemical reaction happen when you pour vinegar onto an egg and soak it? Yes or no?